Good morning, everyone. This is Shauna, and I wanted to make a separate video today on section 6.1. I know there's some content out there that gives you some pointers on some of it, but I wanted to do some of the problems from the homework and show you some of the elements of the slides, just so you can be more familiar with it. It extends our understandings from chapter 3 and the empirical rule, but it also involves a lot of calculator use. So if you're not used to having your own calculator, you're going to need it from here on out for the rest of the course, but you're especially going to need it um, in the next few sections because you won't be able to do it without it unless you want to look up the tables in the book. And if you are using the tables, she does give you that briefly at the end of the slides. But do come and see me if you are using the tables and you need help with that. So let's get on with this. Let me share my screen at this time. I think I'll show you the homework before I show you the slides. So as usual, we start with some comprehension questions before we get to the meat of the assignment. What are the characteristics of a normal distribution? What is the total area under the standard normal curve? And about what percentage of the area under the normal distribution curve falls within 1, 2, and 3 standard deviations above and below the mean. Okay, so one distinction I want to make here first. This is an important distinction for the next couple of sections. I want to show you this. So when we talk about normal, okay, normal, as I've told you before, refers to the shape of the distribution. So normal is a reference to the shape of the distribution or the data, okay? So when you see the word normal, I want you to think bell-shaped. That's what I want you to think about. Or approximately normal, bell-shaped. And for our purposes here, because we have a bell-shaped distribution and because it's normal, this means that the rule that we talked so much about prior to exam 1, which is the empirical rule, applies. So remember, the empirical rule applies to normal distribution. Okay, now, you're going to hear something in this section and in the following sections that you probably haven't heard before, and that is, and this should have S on it. Okay, so I'm going to put an S on it, period. But we're going to talk about something called normal distributions versus standard normal distributions. Okay. The whole chapter is about normal distributions, and that, remember, just means that it's a bell-shaped distribution. Okay. A standard normal distribution is a little more specific. It takes it one step further, and I'm going to show you what I mean by that in just a moment. But for now, I'm going to go ahead and just show you this. So let me go ahead now and get a second whiteboard here. Okay, so here's my second whiteboard. Now, what I'm going to do is I'm going to draw, here's a line, and I'm going to go to, let's see, there it is. Something like this, okay? This is a normal distribution, more or less, okay? This normal distribution has properties, which we talked about in the last section, and we're going to continue to talk about here. But if you remember, the mean, the median, and the mode are all in the middle, okay? And if I have a standard if I have a normal distribution, such that the mean is 0 and the standard deviation is 1. Then I have what's called the standard normal distribution. That's the difference. So if I have a normal distribution and here I have a mean of 0. Let me get a pen that actually works. Okay, so here's 0. And if I'm labeling it like you're used to, 1, 2, 3 standard deviations, right? And 1, 2, 3 standard deviations away. If I'm looking at that idea, this is then I can say that, let's say 1, 2, 3, right? Then these become standard normal curves. This is the standard normal curve, okay? If I had, like we had in one of the examples, here's a curve, and here's my middle section. This is a little better than the last curve I drew. Let's say that here, the mean is not 0. Let's say that the mean here is 100. Okay, so this is 100 now. And let's say that the standard deviation is, let me put some tick marks on this thing. That's a wonky tick mark, but forgive me, the Zoom has some different meeting controls than I'm used to. This is So if my standard deviation is 15, this is now 115. And this is now 130, for example, right? And then this 100 minus 15, this would be 85. And this would be 70, right? Now I could go 3 out, but I think you get the idea. My point here is that this distribution, the one on the right, this distribution is normal, but not the standard norm. Okay. It's not the standard normal distribution. And that's the difference. So if you see the words standard normal, which you're going to see in this section, we're dealing with a distribution like the one on the left. If you're dealing with a normal distribution, but it doesn't have standard here in front of it, then your mean is another number and your standard deviation is probably not 1. Okay, but your mean is not 0 and your standard deviation is not 1. That's what makes this different. And what's going to happen is in 6.1, we're going to learn how to find areas under curves for any amount of standard deviations above or below the mean. And in 6.2, we're going to learn to extend those concepts to any distribution, regardless of what the mean is and the standard deviation are. So let me go ahead now and switch. Let me go ahead and switch screens here. I'm going to go back here. So what are the characteristics of a normal distribution? Well, those are in your slides. So if you go to your slides for 6.1, okay, you have your common phrases, you have some normal distribution curves, we have some values of that. Now, properties of the normal distribution curve, okay. She's looking for that first question, she's looking for all these properties on slide number 10. The normal distribution curve is bell-shaped. The mean, the median, and the mode are all equal. The normal distribution has a single mode, a single peak at the top. The curve is symmetric about the mean. The left side of the curve, the left half, looks like the right half. The curve is continuous and it never touches the x-axis. It might look like it does, but it never does. These are properties of the normal distribution. If you know these properties, you'll be in good shape. One that's not on here, there's more properties here. She also includes this first bullet at the top. The total area under the normal distribution curve is equal to 1, which is the second question on your homework assignment. So here it says, what is the total area? So if you look, this is going to be, let me show you something. this first, this is going to be slide 10. Slide 10. Okay. The total area under the distribution curve is on slide 11. Slide 11. And that's the first bullet. Okay, that's the first arrow that she talked about. Now, about what percentage of the area under within 1 standard deviation above and below, 2 standard deviations, and 3 standard deviations. Okay, that's also on slide 11, part of it. But it's also on, let me take you there. Here's your empirical rule, your 3 bullet points for that. And here she's talking about what percentage lies one stand. Now, this might be confusing for some of you. So let me go over this. When she's talking about above the mean, remember, is right here in the middle by this mu. Okay, so this is the mean here. Numbers that are to the right, so everything here is considered above the mean. It's larger than the mean. Think of this, if this were 100, this might be 115. This is larger in this direction. So above the mean is to the right. Below the mean is to the left. Okay, the further to the left you are, the more below the mean you are. So she said, what percentage of the area lies within 1 standard deviation above the mean? So we know that 68% lies within 1 standard deviation without specifying a direction. 68% lies within 1 standard deviation. But 34% here on the right lies within 1 standard deviation above the mean. 34% lies within 1 standard deviation below the mean. Okay. 34 plus 13.5 is going to lie within 2 standard deviations above the mean. So if you add 34 and 13, you get 47 and then 0.5. So 47.5% lies within 2 standard deviations above the mean. Then if you add 0.15, you can continue that and you can see what we're talking about. So be careful with the question. If you're talking about how much area lies within 1 standard deviation, that's 68, but within 1 standard deviation above the mean, 34, below the mean, 34, and so on. So be careful when you answer that question. But she's testing here your knowledge of the empirical rule that we went over before. Now, the bulk of this section deals with how to deal with areas under the curve. And so she gives you calculator instructions. Okay, so we're going to do some problems. She gives you lots of examples in here of how to do the problems. Essentially, what you're going to do, and you must draw these, okay? You must draw them. That's part of showing your work for this section. So let me go ahead now, and I'm going to hit a couple of these. There's a lot of exercises here. I'm not going to do all of them. I'll do number 5. Find the area under the standard normal distribution curve between z equals 0 and z equals negative 2.14. Now, most of the time we write it from the smaller number to the bigger number. Here she didn't, because she wanted it to match, I think, number 4. But remember, a negative z-score is below the mean. So if you say between 0 and negative 2.14, we're going to have a situation that looks like this. Let me go ahead and share the screen at this time. Let's see. There it is. Okay, so we're going to say, now, here's my board. And I have a situation where I'm going to draw my distribution curve, and I want to find. So my question was, this is number 5. Find the area under the standard normal distribution curve between z equals 0 and z equals negative 2.14. Okay. So what we're going to do is we're going to draw our curve. Okay. Normal curve. You're going to put your 0 line always in the middle there. Now, negative 2.14. There's no way for you to actually totally eyeball this, okay? But you do have to put it on the correct side. This is negative, so remember, negative z-scores are on the left. So somewhere here in the tail, somewhere there. So I'm going to put that, and I'm going to say, okay, here's my box. And I'm going to, let me see here. Okay. I was expecting it to do something, and it didn't, so bear with me for a moment here. Okay, so this is z equals negative 2.14. Okay, there's my, now, here I'm going to say, all right, this is, let me get my colors, let me use that. Okay, so now, here's my point, right? From here over is my area, and you do need to shade. Shade the area you're trying to find. Doesn't have to be pretty. Just has to be semi-accurate, okay? 0, negative 2.14. Now, we have a function on the calculator that will actually tell me how much area this is. What portion of this curve am I taking up with that? And the function that we use for that is normal CDF. I'm going to show you that on the calculator in just a minute. So the normal CDF function, and you'll see why I'm giving you this in so much detail in a second. The normal CDF function on the calculator provides a way to find areas under portions of a normal curve, okay? And the specifications for that, depending on the version of the calculator that you have, but the normal specifications for that are going to be something like left bound, right bound, mean, and standard deviation, which I'm going to abbreviate SD. Okay, that's my format. Okay, so here's what it looks like on the calculator. So what I'm going to do here is I'm going to get my calculator screen. Yes. And I'm going to say, okay, here's my calculator. Share screen. So I'm going to say second, and my distributions are on a menu in the calculator above the vars key called vars, and it has distr on top. On this screen, you have normal PDF and you have normal CDF. I want you to choose number 2, normal CDF, cumulative distribution function. Your lower boundary for this example is the left one, which is negative 2.14. Notice that when I enter the negative, I use the toggle minus next to the enter key, not the subtraction sign. If you use the subtraction sign, negative 2.14, your upper is 0, your mu is 0, and your standard deviation is 1. You'll get an error syntax, okay? Go to. See how this is highlighted? If you have an option when you get an error to go to it, if you see a minus highlighted like this, chances are you used the subtraction sign when you should have used the minus down here by the enter key. The calculator only knows how to read this as a negative sign. The calculator only knows how to read the big one as a subtraction sign. So that's the difference. Here's your answer, 0.4838. Now, traditionally, z-scores are 2 places. That's what you'll see in the book. However, because Professor Nickdell is standardizing everything so that you'll all have the same answers, she's rounding to 4 places. So this is 0.4838. And if we go back to the homework assignment and we scroll down to the answer key, here's our first, there's my answer to number 5, 0.4838. Okay. Number 5 is 0.4838. That's an example of how to use your calculator. Let's do another one. So this this version was okay. So I have another, whoops, I forgot to, before I can continue here, I forgot to get a problem from the homework. So let me do that. Let me do problem number, hold on. Let's do problem number 12. To the right of z equals negative 0.12. Okay. To the right of z equals negative 0.12. So here, we're going to say this is 12. Find the area under the standard normal distribution curve to the right of z equals negative 0.12. Okay, once again, draw your distribution. So here's your baseline. Here's your curve. Remember, 0 is always in the middle. Okay, this is 0. So negative 0.12 is going to be really close to 0, but on the left. So, I mean, this is far out, but I have to have space to write. So this is going to be z equals a negative 0.12. Now, we want everything to the right. So we're going to say that we want everything here. This is everything to the right. Notice it's also to the right of 0. That's okay. I'm looking at this z. Okay. So what I'm going to enter in my calculator, remember my normal starts where the boundary starts from left to right. My region that I shaded starts with negative 0.12. So when I write this, I'm going to say this. I'm going to say normal. So I'm going to say that I have normal CDF from negative 0.12, comma, where does it finish? Well, this is infinity over here. The way we write infinity is we say E99. Our shorthand is E99. So we're going to write E99. Then the mean, which is 0, and the standard deviation is 1. These are defaults, 0 and 1 in the calculator, so you don't have to write them in. But unless they're different. But I always get in the habit of writing all four. So remember, left bound, right bound, mean, standard deviation. This is our um, element, and we get, oops, pardon me. We get, I'm gonna go ahead and do share screen. This is gonna be second distribution. Remember, that's on top of ours. We're going to have normal CDF number 2. My lower is going to be, in this case, it was negative 2.14. Wrong. Okay. Negative 2.14. My upper is not 0, it's infinity. So I go second. Now to get infinity, you have a couple of E's on your calculator. There's an EE here above the comma. There's a letter E here above the sign. You want the EE key above the comma. That's what you want. So you're going to go second E, oops, second E, and you're going to go 99. Exponent 99 is what that is. And then we're going to paste it, and there it is. 0.9838. So once again, we have okay, this is our, that was number 12. Oh, my apologies. It was negative 0.12. My bad. So let me put it in again. Negative 0.12. The thing still holds, but I have negative 0.12. So here I've got, I was mixing it up with the other number. So this is negative 0.12. So what we have is second distribution, normal CDF. This is I'm gonna fix this, negative 12.12 E99. And we're pasting it, and we get 0.54775. Remember, this 5 makes this second 7 and 8. So 0.5478. So here, we're going to get number 12. And there it is, 0.5478. Now, the only difference in the next group of exercises, in 14 through 20, is that instead of giving it to you in words, She's given it to you as a probability. So here, 14 between 0 and 0.92. She's giving you the left and the right. So here, this is 0. The right one is 0.92. Here, the left one is negative 1.43. Here, it's 0. Now, if I do, say, 16, okay, 16 is going to look like this. 16 is going to be something like, here's my curve. There it is. And I'm looking at greater than 2.51. So I'm going to draw my 0 in here like that. That's 0. Negative 2.51 is going to be somewhere here. Let's say right there. Okay. That's going to be negative 2.51. So now Z here is going to equal negative 2.51. And all I'm going to do is shade. It's greater, so I want it to be bigger, so I want it to go this way. So when I write my answer, I say this. I say probability of Z greater than 2.51 is equal to normal CDF from 2.51. Where do I finish? Well, I finish at infinity. So I'm going to say 5.1, say E99, and again, 0 and 1. Put it in your calculator. Let the calculator do the heavy lifting for you. Okay? So there's my situation. And what I'm going to do here is I'm going to say, let's go ahead and share the calculator screen. So I'm going to have, this is going to be second distribution, normal CDF number 2. This is 2.51 E99, 2.1 E99, 0 and 1, paste it. And what I end up here is 0.0060 with a 3. So 0.0060 is my area or my probability. So now I have this. I'm going to come back and say, clear my drawings out. Let's see. And I'm going to go ahead and scroll down. And look at number, what number was that? That was number 16. So let's look at 16. There it is, 0.0067. Now, there's one other thing that I need to show you. If you remember, I said earlier that I'm going to show you the calculator again. I said that the function normalcdf finds the area under curves. Okay. What if we have a situation where area is given to us and we'd like to find the z-score? Is that possible? Well, it turns out it is. Okay. So let's look at number 23. Okay. 23, we have a distribution. 0 is in the middle of it. And we have some z-score over here on the left that we don't know. Now, because it's on the left, we know that it's negative, but that doesn't help us very much. Okay, we know it's a negative z-score, but we do know that the area from that z-score all the way to infinity was 0.8962. Okay, and we know that the total area under the curve is 1. So here's what we're going to do. So earlier I said this. I said, when we look for areas under the normal, under a normal curve, we use normal CDF. Okay, but when area or probability, because sometimes it's written as probability, is given, and we want a z-score, we use inverse norm. Inverse norm. Okay. Now, that may seem counterintuitive. I'm going to show you what I mean here. So before we do too much here, I'm going to show you something. Inverse norm is number 3 on your list here. Notice that your inputs are slightly different. You don't have a left and a right here. You have area. Okay. Area, mu, sigma, and pace. Okay. Inverse norm area. Now, so compare that to normal CDF here. Second distribution, normal CDF right here. And I'm not sure why it's doing that to me. Let me quit from here and try again. Second quit. Okay. Let me try. Second distribution. Sometimes the emulator acts a little weird. If it does that, I haven't figured out why it does that, by the way, but normal CDF, I'm just reminding you, has these inputs. Inverse norm doesn't. Inverse norm has these inputs. Second distribution. Inverse norm here. Okay. Nope. My apologies, folks. It's not cooperating here. Second distribution. inverse norm has these inputs, okay? Now, the area that you're going to put in, some calculators will let you set this to left, center, right, but this defaults, and the one that you should always use for this class is left. So we're always going to use area to the left. So when you have, now, that brings up an interesting question, and this is why I wanted to do this problem in particular. Sometimes they give us the area to the left. Sometimes they don't. Sometimes they give us the area to the right. So look at this here. If I'm going to do the z-score, which is what I want, okay, then what I'm going to have to do here is I'm going to say that for this one on top, my format is z is equal to inverse norm, and it's the format is area to the left of z, mean, and standard deviation. That's the format for your calculator, okay? So this means that here I would do z is equal to inverse norm, and I would put in, here I would put in what they give me for 22, 0.0188, 0188, if I can type correctly, there we go. Mean is 0, standard deviation is 1, remember, because we're on the standard normal curve. That's what 22 would look like. Now, 23, they don't give us the area to the left. They give us the area to the right. So guess what we have to do? We have to use our brain, and we have to give the calculator the information it wants. The calculator wants, okay, so we have this area here. We have this area in the beige or the yellow or whatever tone this is showing up for you on your screen. We have this, but that's not what we want. We want our calculator's not happy because we want this area here. Now, why do we want it? Because that's the way the calculator's been programmed. It's not because you can't do this any other way. If you use charts or tables or other methods, you can use this number. But the calculator is programmed to need this area on the left. So we have to give it the area on the left. Now, what do we know? We know that the total area is 1. So we're going to say that the area to the left of z is equal to 1 minus the shaded region. 1 minus the area of the shaded region. So what does that mean? That means we get area to the left of z is going to equal 1 minus 0.8962. 0.8962. Now, you can simplify that, or you can just write it in. Z equals inverse norm of my area, which is 1 minus 0.8962 my mean is 0, and my standard deviation is 1. So here's what this looks like. I'm going to go ahead and do my calculator, 0.188 and 0.8962, 0.188. So here I'm going to say there it is. And my other one, second distribution, inverse norm. Here I'm going to say 1 minus. Now this time I do want the minus, okay, because I want 0.8962, 0 and 1, paste it in. There's my number. So those are my answers for, remember this 9 makes this 1 and 2. So let's go back. 2.0792 and negative 2.0792 and negative 1.2602. So we're going to say that was 22 and 23. So we have, here they are, negative 2.0792 and negative 1.2602. I hope that this brief explanation of some of the problems in section 6.1 has helped you. I don't think you'll find them that difficult. The next section is very similar, but it's going to deal with distributions that are not standard normal, but they are still normal. But anyway, I hope that this has helped you, and I hope to see you in my next video very soon. Bye for now, everyone.